No, I think this is going to be a really interesting conversation because there's this huge debate and there's this huge sort of like, I'm almost tempted to say fight going on between some engineers about which technologies reign supreme, IGBT, silicon carbide, silicon, GaN. But I think the conversations we've had has sort of revealed the truth of the nature. So just sort of for the sake of the audience, just tell us a little bit about what's really going on when comparing these technologies.
The thing is, when you kind of are in an argument about what's better for what and so on, there's no like black and white. There's always like gray scales. And for example, look at flyback topologies.
Yeah.
Like AC to DC, we're looking like 110 volts to what 12 volts or something. If it's about size and efficiency, then use a GaN flyback. So because you're switching fast, you have a high switching frequency, and so this is making the flyback transformer smaller, the whole device is smaller. I mean, you see this modern USB Type-C phone chargers and notebook chargers, incredibly small. That's not possible with silicon. And when it comes to, I mean, that's GaN at the moment stops at 640-ish. There is silicon devices, so silicon MOSFETs, IGBTs. There's in that same range silicon carbide, and then there's GaN in the same range. So what should I pick? And it's always down to, let's say, the topology and the end usage where I'm going. Motor drives, it will stay a playing field in the higher power range for silicon carbide IGBTs. In the lower power field, you can have a conversation about GaN, but you need to be aware lots of the motor drives work in a way that they can be overloaded.
And this comes down to the issue with the body diode in the GaN structure itself.
Overload, not. Overload is just with the size of the GaN die itself.
Oh, okay, yeah. So it's too much current going through something too small, whereas that situation is more about things like back EMF and overcurrent and stuff.
Yeah, when it comes to motor drive for industrial applications, for example, you have a emission profile, you have a peak load, you have an average load, and a minimum load. And the power electronics to achieve that kind of load profile is never designed in a way to be continuously able to support the peak load. It's an overload case you're looking at. But the thing is, industrial motor drives need to have a lifetime for like, 10,000, 12,000 hours. And you can simulate and calculate the wear down of the module. So you are in a, let's say, controlled wear down of the module to achieve the lifetime, but not over designing the thing. For GaN, overload is not the thing you can do, really. And so you need to be aware that you need to design for peak load. And this does take the fun out of the equation, really, because it's then bigger and more expensive, and then it's like, where's the point to use that one? If you have like a few 100 watts motor drive for a fan or whatever, fine. There's no discussion there.